Yes, welcome back. So, in the earlier videos, we've been discussed the analysis of four-bar mechanism. We've been discussed about an introduction of velocity and acceleration of analysis. So then we have been discussed about the slider crank, piston, and velocity. We have been discussed. Now we're going to solve one of the numericals in order to find out the how we can able to find out the different conditions for a given slider crank mechanism. Is the given the mechanism as shown in the crank will be having a 50 radius which rotates at 2000 revolutions per minute. So determine the velocity of the position for the position as shown. What the position they have been. Also determine the angular velocity of link AB about A. See, they mentioned as in two conditions. So first we need to find out the velocity of the piston for the position which they have been mentioned. See, for this position we need to find out the velocity of this particular piston which they have been mentioned the position. This is one condition, and second one is, so we're going to determine the angular velocity of link, angular velocity of this AB when it is about, when means we're going to consider from A only. We need to find out the angular velocity of AB, but here we need to find out the velocity of the piston for at this particular position, and second one we need to find out the angular velocity of this link AB with respect to, means only we are by considering that from point A. So now we can able to see this diagram. So the distance between A and B they are given as 90 and from the distance between A to the O fixed point is 50 with an angle of 30 degree, and this will be this mechanism is rotating at 200 revolutions per minute. So it will be rotating at 200 revolutions per minute. So based on these conditions, we need to draw here. Actually, we are not able to consider with an exact dimensions. But when solving, when the students they have been solving, they need to consider the scale as based on that whether 1 centimeter will be equal to 1 meters per second or 1 centimeter will be equal to 10 meters per second. So based on the conditions or based on their scale, they can able to consider this. So now, see, as we told that the diagram should be as per the scale, and even the student should has to use the scale whether the 1 centimeter will be equal to 1 meters per second. So and one more thing is the important is so that the direction at 90 degree to the link KB can be transferred to the velocity diagram. See, because we need to, after finding the values, we need to transmit the values what we got. We need to transfer that values in the form of a velocity diagram. Now, angular speed of the crank M they have given, that is the formula is 2Wn by 60. 2Wn by 60. So here 2W, that is N, we know that 2000 revolutions per minute and 60. So we know the speed, but we know what is the angular speed of the crank. Now we got that is then a 209.4 radians per second. So now velocity at that particular is m into the radius. So the radius is what the radius O is, we got as in a 0.05. How we will consider that 0.05 is, so the 50 mm which is the radius is there with the 50 mm that we have been converted into the meters, right? So now the radius m is nothing but what we got, the angular crank m is 209.4 into 0.05. So now the maximum angular speed of the crank radius will be 10.47 meters per second. So now we got angular speed 209 and then a radius of angular speed of a crank radius is 10.47 meters per second. Now based on this values what we got and earlier what the data they have given, based on that we need to find out the, or we need to draw the vector diagram. First we need to draw in a vector diagram, then we need to draw the line of the direction, then finally we need to add the line of direction of OB to find the point B and measure OB to get the velocity. See, based on these diagrams, now again we need to draw the first vector diagram, then the direction, then the velocity diagram, then we need to measure that values, and then we need to find out the velocity of the piston position and velocity of a link A to B when it is fixed about the A. Yes. Now drawing the vector diagram O to A. Now by considering the 10.47, what the 10.47 value what we got as in a radius, so that we have been drawn a line of from O to A, it is a 10.47. So similarly O to A is a 10.77 value what we have been, and we have been extended the one parallel line to this which will be in this particularly this to obtain the B. Now where the third diagram we can able to see, now we have been joined that straight line to the exact 90 degree which the value is there. See, this O to B is then which is bearing in a 45 degree, and now we have been joined that O to B within an exact straight line. Now what happens when you join to the exact straight line? Now the value is 10.0447 radius what we got meters per second. We have been drawn line to draw a line up from O to A. Now we have formed as a triangle one AOB which is moving in this directions where you can able to see O to A, again from A to B, again from O to B. Yes. So now the relative velocity of B to O is 7 meters. Now after this, when measuring from relative to B to O is, when you want to measure the distance, the distance is 7 meters per second. Now the tangential velocity of B relative to A is the vector AB, and this is vector AB is now gives us a 9.2 meters per second. See, now we're going to measure from distance A to B, we're going to get as a 9.2 meters per second. So from A to O is already we got 10.4. Now from O to B, when you're going to measure, you're going to get the one value, and from A to B, we got another value, that is 7 meters per second, and vector AB, and that gives the 9.2 meters per second. Now the angular velocity of P about A, we need to find out the second condition. One is the tangential velocity of B relative to A is vector AB, that gives us a 9.2 meters per second. And similarly, the angular velocity of B about A is found by dividing the radius of that radius of length AB. Now initially what the value we got for M for AB is 9.2 by 0.09, that is we have been converted that value. So now we got as a 102.2 radians per second. This is the relative to A, and it is an absolute angular velocity. So it is which is related to A, and that is the absolutely about an angular velocity. So that is how we have been identify the values. Now coming to that bar chart means how it's going to be analyzing the problem is, so the input link rotates at a constant angular velocity for M1 for the condition of 1 at M. The relative velocity of each point relative to the other end of the link has been shown. You can able to see in this diagram. So the relative of this both the links will be having relative to each links from O to A to B, B to O. So it will be having a relative velocity of each link, and each velocity vector is at right angles to that particular link, and the output angular velocity is m2. This will be not be constant even if you want to find that velocity, and the points A and D have been fixed. So this will be how it going to be effects in this diagram. So mainly now based on these two conditions, what the given value is there, we have been satisfied that given conditions. So we have been identified that the both the values, one is based on the relative of the piston and based on the angular velocity. So we got as in a 9.2 meters per second and 7 meters per second. So this is how we need to analyze, or how we need to find out the velocities of both the given conditions. Thank you.